Good afternoon, friends. Welcome to my second video lesson on chapter 3 of physics. So in this video we are going to learn about the power of machine and efficiency of machine. We will also look at some numericals on power and efficiency of machine. Let's see power first. We have also seen power in previous video, but there was a little bit touch only. So power is a measure of how fast or how the work is being done. Now if two people does certain kind of work, same kind of work, someone who is doing it faster in shorter duration of time is said to be more powerful. And in short, power is defined as rate of doing work. SI unit of power is joule per second or watt. The formula to calculate power is work done over time, or we also say in short we read this as a rate of doing work. Power is rate of doing work or rate at which work is being done. So there are several units of power. The most common unit of power that we use is watt, W-A-T-T, watt, and there are bigger units like a kilowatt, megawatt, gigawatt. There is also another unit called horsepower. 1 horsepower is equal to 746 watt. A machine may be simple lever, combination of pulleys, or gear system, or any complex machine. Some machines are used to multiply force and some just to change the direction of effort. Like a simple pulley, a single fixed pulley is just used for changing the direction of effort. When we pull something from underground or from the lower level, difficult to pull against the gravity, and just to make it easier we use single fixed pulley to change the direction of effort. Power of machine is the rate at which machine does a given work. So rate of doing work for machine is called power of machine, and a machine which does more work in shorter time is considered as more powerful machine. Now for machine we can have power of machine as a force times velocity. So this can be the formula for calculating the power of machine in short or in nutshell. Now next one is an example on power. A man pushes a box to a distance of 5 meters with a force of 100 Newton in 10 seconds. Distance of displacement is given here, and the force applied is given, and the time is given. What is the power developed by a man? So what was the man's power? Force is 100 Newton, 5 Newton of displacement, and 10 seconds of time is taken to displace the body. Now first we will apply the power, formula of power. Work done is, power is work done over time, and here we are replacing work done by F times D, because we know that work done is F times T, force times displacement, or it is F D cos theta, but we assume that the box is being displaced along the direction of force applied, so we are taking angle as 0, considering angle as 0. Whenever the angle is not given, we can consider the angle to be 0 and go with the work done is F times D only, and work done divided by time. So we have got power is force, we have 100 Newton, and displacement is 5 meter, and the time is 10 seconds. So in calculation, while calculating, we get 500 over 10, so that is 100 watt. So power developed by a man is 100 watt. Let us look at another question here. Mr. Pema carries 60 kg rice bag on his head to 4-meter high building in 25 seconds. What is the power of Pema, or how much power is developed by Pema? And we are asked to take acceleration due to gravity as 9.8 meter per second. Now mass of rice bag is, mass is given 60 kg, and height. So here we are not taking displacement, we are taking height instead. It is because we assume that man is climbing vertical height. Usually buildings are vertically stiff, so we climb up instead of carrying and running through the horizontal distance, and time taken to walk 4 meter carrying the bag is 25 seconds, and acceleration due to gravity also is given. So applying the formula, in short we can write now, before we wrote work done as F times D, but this time we are going to write work done as mgh, because the man is carrying the bag and we're going against the gravity. So this is work done against gravity. Even when people load the truck or pulling some water from the well, so when the people is working against the gravity, so we can use mgh. Now work done here, W is given by mgh, where time is same. So on substituting value, m is 60 kg, then acceleration due to gravity, g is 9.8 meter per second square, and height of the displacement or height is 4 meter. Divide by time taken is 25 seconds. So on calculations we get 2352 divided by 25, and that gives us the power as 94.08 watt. So that is the power developed by Pema while carrying the bag of rice for to 8 meter high. We come across efficiency in daily life. We use this word very often. Some people say he is very efficient at work, because someone who does work very well without wasting time is known to be as an efficient person. But in machine we say, if the machine gives 100% output, we give certain input into the machine, and if the machine gives us 100% output, that machine is considered to be 100% efficient. But as we discussed earlier in the first topic, that on earth there is no such machine called idle machine which gives us 100% output. Now output in the machine can be given in terms of electrical energy or chemical energy. Just to give example, you apply fuel in the fill fuel in the bulldozer, and it gives us output work by pushing some boulders or digging. So that is, input work is given in terms of chemical energy, output work is given in terms of some physical work done. The force applied to a machine is called input force, and energy supplied to a machine is also input energy, and force applied by machine is called output force, or energy given out by machine is called output energy. Work done on the machine is called input work, work done by the machine is called output work. So these two concepts are very important for us to understand the formula for efficiency of machine. Efficiency is defined as ratio of output work into to input work. So this can also be defined as ratio of output energy to input energy. Now here, efficiency percentage. You can also calculate efficiency only, but you will get in decimal point. So when you calculate percentage, we are adding 100 multiplying by 100, output work divided by input work. So this ratio, when you multiply by 100, we get efficiency of machine in percentage. Then the second one, the efficiency of machine in terms of energy can also be given, like efficiency energy output divided by energy input times 100. And sometimes we have a machine which moves, like a pulley lifts the things, we move effort and we move the load. Now in that case, the efficiency of machine can be calculated by using load times displacement of load divided by effort times displacement of effort. So load here is the amount of load that is tied at the other end of the pulley, and displacement of load means how fast the load moves or how far the load is displaced. Then divide by effort is the input energy that we apply to the pulley, and displacement of effort. So how far our effort moves as we pull the rope. In short, we can also write it as efficiency. We call this letter as inter, and it looks like an N with a longer one end is a little longer. L times dl divided by E times dl. Sorry, this is dE, E times dE. So this one is distance moved by effort times 100 is just to convert this efficiency into percentage. Now using this formula we can calculate later on. Now a machine having 100% efficiency is called idle machine. Now do you think that there will be a possibility of having an idle machine on Earth? Think for a while. There is no possibility of having idle machine on Earth because every machine has weight, and as the machine has weight, automatically there will be friction, and certain amount of energy input that we give will be definitely converted into other form of energy, and that we call it as a dissipation of energy. Some amount of energy is always dissipated in the form of heat, sound, or light. Now let's go for one example again. When 550 joules of work is done on the machine, it gives useful output of 420 joules. Find the efficiency of machine. Efficiency of machine is output work divided by input work, or you can also say work output divided by work input, but output should be on the numerator, input should be in the denominator, times 100. We substitute the values. Output is 420 joules, input is 55 joules, and in doing so we get the efficiency of machine to be 76.36%. I hope this is clear. There is some error here. Alright, now next question. Example 2 is Chimmy applies effort of 350 Newton to lift a bucket of water from well using single fixed pulley of 90% efficiency. How much load can Chimmy lift from the 3 meter deep well? So height of the well is given as a 3 meter. Well is usually in olden times, especially in the plain area, people used to dig underground. They used to make a deep hole underground and fetch water from that deep well using a pulley. Alright, so this person is applying effort of 350 Newton and pulling the water from the underground. Now 90% efficiency, the machine is of 90% efficiency, and that we can write it as 0.09 in decimal point. We don't write it in the percent directly. Then height is given. Alright, now what is given thing here? 350 Newton effort is given. Displacement of load is always equal. In single fixed pulley only is true. So in single fixed pulley, when load moves 1 meter up, definitely this effort will also move 1 meter back, because there is no much complication here. I think it's direct. We understand that when load moves up, the same thread is moving that side. So when load moves 1 meter, this effort will also move 1 meter. Now in this case, displacement and both are given as 3 meter. So displacement and load is always equal for single fixed pulley only. If there are double pulley, movable pulley, then block and tackle, that things will be different. So you must have learned this in class 7, but you can refer if you want to go for further detail. Then we are asked to find load, which is missing here. So load is the missing thing, and efficiency percent is, again we can use the same formula. Load times displacement of load divided by effort times displacement of effort times 100. In short, again the same thing is here. In short, we can write load efficiency is equal to L times DL divided by effort times DE. DE is the displacement of effort. Now next, when you substitute, we have efficiency is 0.9. As I said, we have already converted it, 0.9, and load is L, we don't know, we have to find this, and this DL and DE we have got same because both of them move equal. Now next, what we do, we can cancel this 3 because both are same value and they are in numerator and denominator. Now what we are left with is L is equal to 350 times 0.09. So this will go to the other side because we want to keep L as a subject of formula and separate it. Now next step, L is 315 Newton. So load, the weight of the load is 350 Newton. Alright, load is 315 Newton. Now let's recap once. So what we have seen so far. So firstly, power is defined as rate of doing work, and the formula to calculate power is work done over time. And if the work is done on horizontal surface, we use F times D over time, and if work done is against gravity, we use mgh over time. SI unit of work done is joule per second or watt. A machine that has 100% efficiency is called iron machine, and it is not possible to have iron machine on Earth. So that's all. Thank you all. And follow safety precautions to combat COVID-19. Let us all work together in saving our nation. Stay home and stay safe. Thank you.